Good day, learners! Welcome to our first video lesson for Quarter 3 in Grade 11 Mathematics. We have finally reached a new chapter and we will now discuss entirely a new subject which is about statistics and probability. I hope you enjoyed the lesson with me until the rest of the video. To start, I would like to request you to pause for a while for our prayer. Our Heavenly Father, we thank you for the opportunity to begin this new day. As we begin our class, we ask you to give us the knowledge and wisdom that we need to help us in understanding our lesson today. Please bless my students and help them as they grow. May I teach them faithfully the things they need to know so they may face the future knowing they're prepared. We pray that you will guide us in all ways so that we will seek your will in everything that we do. We bring back all the glory and honor. In Jesus' name we pray. Amen. Before we get started, make sure that you are in your most convenient learning spot. Get yourself ready and prepare your Module 1, your notebook, and your pen. Keep your gadgets away from you and direct your attention to our class. Alright, so before anything else, let me just enumerate with you the objectives that you will be able to meet at the end of the lesson. First, illustrate a random variable, discrete and continuous. Next, distinguish between a discrete and a continuous random variable. And lastly, find the possible values of a random variable. We have an exciting way to begin with our lesson, using ClassPoint. In the real time, you will join first the class through the link classpoint.app on any browser using the code in the top right corner of the presentation. But in this video lesson, you can just write your responses on your paper within the time limit. Once the timer ends, you can no longer give your response in ClassPoint or on your paper. Allow me to read the question to you first, and then the timer will automatically start after. You only have 2 minutes to answer. Are you ready? Let's go! First question. How are you feeling today? Okay, so I hope you're all doing well and ready to venture to another learning experience in grade 11 mathematics. Next, what did you eat for breakfast? Reminder, don't skip your breakfast because it is the most important meal of the day. Next question. Kumusta ang pagmo-module? not forget, all your hard work will pay off soon. You can do it! Okay, another question. What profession do you want to do in the future? So let that career goal motivate you to study hard today. Dream big and work hard. Another one. Where do you want to go on vacation? We will be using the class points word cloud question type to visualize your responses. Also this time, you can add multiple submissions in ClassPoint if you had more than one answer. Okay, so some dream of going to major tourist attractions, Some want to go for a trip abroad or visit other countries. Okay, so I hope that you've already started planning that dream location to turn it into reality soon. Okay, most of you want to go to the beach, and to make it really happen, others simply prefer their vacations to nearby towns in Bicol and probably other places in the Philippines, or to travel somewhere affordable. Okay, so with your responses and to also introduce the subject, here is my follow-up question. What is the chance that your desired vacation will happen soon? Likely or unlikely? Impossible or certain? Or some may say 50-50. What does that actually mean? This phrase has something to do with probability. If you still recall in grade 10, probability tells you how likely it is that an event will occur. This means that for certain events, you can actually calculate how likely it is that they will happen. The chance that your vacation will occur soon may have not been certain with the COVID-19 pandemic still going on, since there is still risk in travel. Even if you're already fully vaccinated, there are still places you'll need to take precautions, especially if you're flying or traveling to an area or country where COVID-19 community spread is high. Coronavirus hasn't disappeared, but we can still take a vacation in another place to get away and recharge, which is important for our mental health, provided that we strictly follow the safety, social distancing, and hygiene measures. So as you can see, if you can still recall your lessons in grade 10, each response or every answer submitted here through ClassPoint can be considered as an outcome, with all the travel destinations or places for vacation as the sample space, for the experiment of knowing what place the class wants to visit for vacation. So if you are already familiar with word clouds, you know that the more times a word is submitted, the bigger and bolder it becomes. So this means that some of you coincidentally or by chance gave the same response, meaning both of you want to go to the same place, and the analysis of this data involves statistics. As you may have noticed, statistics and probability enabled us to answer all these questions, make decisions based on data, and make predictions. If the question requires data, it can be answered using statistics. If it is more about chances or possibilities, we use probability. We need it to know who turned out in the poll during candidacy and predicting election outcomes. Questions such as how likely it is that there will be rain on a given day in Bicol, in a weather forecast, or what is the chance of me winning in the lotto? In this case, we apply probability. Teachers use statistics to know the average score of the students in a test, or if they want to know the preference of different students in a class. They need to conduct survey online via Google Form or poll in a group chat. This also involves statistics. To further introduce the new subject, let us watch a short video about the brief history of statistics and how it was linked to probability.
Statistics is a word that originated from modern Latin statisticus, meaning state affairs, due to its association with the collection of economic and demographic data by states. The inauguration of statistics can be traced back to early civilization, as early as 3050 BC, wherein ancient Egyptians recorded data regarding wealth and population. Further census data was documented in China in 2300 BC, Greece in 594 BC, and in particular Rome, whose people recorded births, deaths, and comprehensively surveyed the country. The information collected during these early times formed a basis for the development of statistics to follow. The following timeline has been adapted from notable contributions and events found in Eve's A Very Brief History of Statistics written in 2002, Laplace to Recent Times written by Guruchun, 2016, and Hold in 2003 a history of probability and statistics and their applications before 1750. The beginnings of calculus of probability was undertaken by Italian mathematician Cardano in 1565, wherein he calculated the odds of winning in games of chance such as dice games and attempted to solve the problem of points. Almost 100 years later, this idea was taken up again through communications between Blaise Pascal and Pierre de Fermat concerning further developments in calculating games of chance. The year of 1654 was the official birth of probability theory. Probability and statistics are inherently linked. In fact, modern-day statistical theory is derived from earlier discoveries. Data in the 17th century comprised of birth, death, and trade records, taxes, and credits of the population. Analysis of this data was initiated by John Graunt in an attempt to understand plague mortality and economic data. In 1662, Graunt provided the basis of 3 statistical investigations, which were political arithmetic, testing the stability of statistical rations, and the calculation of expectations of life and survivorship. Following the release of this information, Petty applied Graunt's method of analysis to economic data, who officially coined the term political arithmetic. Nicolas Bernoulli later used this information to compare data relating to male births to estimate probability of outliers in relative data. Christian Huygens utilized Graunt's investigations to calculate the median and average lifespan and survivorship probability of a person at any given age in addition to his work on games of chance. There began the early history of life insurance mathematics backed by mortality statistics, an endeavor undertaken by the state to raise money for public purposes. James Bernoulli, Montemort, Nicolas Bernoulli, and De Morve were notable contributors to the following decade, publishing some 4 textbooks in as many languages, which took a number of years to be studied in depth. Lagrange and Laplace found 3 problems left by De Morve and continued to investigate his work. The 18th century witnessed the early beginnings of statistical theory and a systematic collection of empirical data. It began with Gottfried Eichenwald, who was a professor of philosophy at Göttingen University, first employed the word Statistik in German. In 1750, a mathematical theory of errors and estimation emerged. 1787, Dr. E. A. Zimmermann introduced the word statistics in English, and then in 1790, the United States' first decennial census of population occurred. The 19th century was an interesting time for statistics. 1801 saw England and France began periodic census taking. 1803, Société des Statistiques de Paris was founded. Belgium's first census was undertaken in 1829. The Royal Statistical Society of London opened in 1834. The American Statistical Association, 1839. 1853 was the first meeting of International Statistical Congress. In the years that followed the post-Crimean War, from 1854 to 1856, Florence Nightingale analysed death rates, which led to changes in the organisation and reporting of British military statistics. A great leap happened during the following years with a large expansion in the field of statistics. All civilized countries now make continuous records of births, deaths, marriages, and divorces. There is now detailed statistical information regarding production, foreign and domestic commerce, finance, public utilities, labour, agriculture, education, and immigration.
You see, statistics and probability are all around us, and this influence our lives every day. Napagtanto mo na ba ang kalagahan ng statistics and probability noon hanggang ngayon? What do you think is its importance, especially now that we are living in the information age? Can you give other real-life applications of statistics and probability? Great! Now, before we proceed to the lesson proper, let us define first some of the common terms that you will encounter when dealing problems in statistics and probability. First and foremost is statistics. Ano nga ba ang statistics? The term actually comes from the word state, because government have been in the statistical activities, especially the conduct of censuses. It is defined as a science that studies data to be able to make a decision. It involves the methods of collecting, processing, summarizing, and analyzing data in order to provide answers or solutions to an inquiry. So, kapag sinabing statistics, kung may magagamit man na datos, nakatutulong ito sa kahit sino para makagawa ng mas mahusay at mabuting desisyon. Bukod dito, ginagamit din ito para mabigyang solusyon ang isang problema. Ngayon, alamin naman natin kung ano ang probability. It is simply how likely something is to happen. Whenever we're unsure about the outcome of an event, we can talk about the probabilities of certain outcomes, how likely they are. The analysis of events governed by probability is called statistics. Okay, so we need to differentiate statistics from probability since these terms are sometimes interchanged and are being closely used. Take note that statistics refers to data, while probability pertains to possibilities or chances. Also, statistics involves the analysis of past events. On the other hand, probability deals with the future. Okay, another terms. Universe. It is a collection or set of units or entities from whom we got the data. Variable. It is a characteristic that is observable or measurable in every unit of the universe. Population. The set of all possible values of a variable. Sample. It is the subgroup of a universe or of a population. Outcome. Each possible result of an experiment. Event. A subset of the sample space of an experiment. Let us now consider random statistical experiment or random experiment. It is an activity that will produce outcomes or a process that will generate data. The outcomes have a corresponding chance of occurrence. It is any procedure that can be repeated, theoretically, an infinite number of times and has a well-defined set of possible outcomes which cannot be predicted. Okay, so here are some examples of a random experiment. First, tossing 3 coins and counting the number of heads. Next, recording the time a person can hold his or her breath. Another one, we have counting the number of students who are watching the video lesson today, and also obtaining the height of a student. So along this topic, you will be encountering experiments like rolling a die, drawing a card from a standard deck, and so on. As we will see from the given examples, an important detail of each experiment is its set of possible outcomes called the sample space. So it is, again, the list of possible outcomes in a random experiment, usually denoted by S. So to review your understanding about sample space, let's consider these examples. First, a random experiment of rolling a single six-sided die. What do you think is its sample space? Great! So we all know that a roll of a die has an outcome which cannot be predicted in advance. If we are interested in the number of spots on the topmost face of the die in this random experiment, then the sample space is 1, 2, 3, 4, 5, 6. Another one. A wheel is divided evenly into 12 sectors, each numbered from 1 to 12. The wheel is spun once, with an arrow fastened at the top of it. So at any time, a certain sector with a corresponding number will land on the arrow when the wheel stops spinning. This is a random experiment since we cannot predict the outcome of the spin. Therefore, the sample space is the whole numbers from 1 to 12. Okay, we have listed all the possible outcomes in a random experiment in the previous examples. But in many situations, we may not be concerned with the details of sample space. Instead, we refer to a quantity defined in a random experiment or a certain numerical description of its outcome. These quantities have values that are not fixed, or their values vary in every random experiment. For you to understand the concept of these quantities that do not have fixed values, let's take a look at these examples. First, the number of accidents at a given road intersection in a month. To illustrate, we all know that its values depend on many factors that are random and change from month to month. Therefore, it is not a fixed quantity. We also have the sum of spots when a pair of dice is rolled, the number of customers that enter a department store in a minute, the amount of rainfall in Bicol in a year. Sa rupang halimbawa ay kumpirang dialekto sa tataramon na Bicol ang aram kan mga Taga-Legazpi. In the study of probability, we call each of these quantities mentioned in the given examples and those defined in other random experiment as random variable. Dito sa subject, importante na malaman natin lahat ng mga posibleng values ng random variable para mabilis o madali nating makuha ang sagot kung alamin natin ang probability sa isang experiment. Exception to this is when we looked at the probability of, say for example, getting a lunch with an apple and a banana cake. This was the result of a chance event, but it was not a random variable as it was not a number or a quantity. The term random is used to emphasize that the value of the quantity arises from a random experiment, the outcome of which cannot be predicted with certainty. The term variable refers to the value of the quantity that is not fixed. Kasi nga, di ba, halata naman sa pangalan niya na random. Hindi pa natin alam kung ano ang magiging value niya. So, we can determine the value of this variable by chance only. Let us now look for the definition of random variable. So, it is a function that assigns a unique real number to each element in the sample space. In other words, a random variable is a real valued function whose domain is the sample space S. So, it is a way to map outcomes of a statistical experiment determined by chance into a number. In other words, random variables are really ways to map outcomes of random processes to numbers. So, a random variable is simply the result of a chance event that you can measure or count. It is called a random because it can take several different values and is the result of a chance happening. This is illustrated in the given figure, where the random variable x maps the sample point E from the sample space S to the real number line. Para hindi malito, ulitin ko na di dapat natin pwedeng tawagin ang random variable na random o isang variable sa tradisyonal na kahulugan nito o ibig sabihin sa algebra, kung saan hinahanap natin ang value ng isang variable. It is technically a function from space of all possible events to the set of real numbers. Okay, a random variable is usually denoted by uppercase letters, oftentimes X, Y, or Z. So it is typically represented by a capital letter, usually X, sometimes Y or Z. Also, a particular value of a random variable X is usually denoted by a lowercase letter, say X or K. So we use this small letter to represent a certain value of a random variable. For us to understand better the concept of random variable, take a look in these examples. Example 1. In this problem, the random variable is the sum of spots when a pair of dice is rolled. So, paano ngayon natin mahanap yung mga values ng random variable? Bago natin sagutan ito, importante muna natin malaman kung ano ang experiment sa problem. The experiment is rolling a pair of dice. So, to solve this problem, the first step is to get the sample space. Since each die has 6 equally likely outcomes, so the sample space is 6 times 6 or 36 total possible outcomes. Let GR denote a possible outcome of rolling the two dice, with G the number on the top of the green die and B the number on the top of the red die. Note that each of G and R can be any of the whole numbers from 1 through 6. Para madaling mailista lahat ng posibleng mga outcome, gagamit tayo ng table of outcomes. We use rows to represent the possible outcomes for green die and columns to represent the possible outcomes for red die. Then, we simply fill in each cell of the table where the rows and columns intersect with the possible outcomes by pairing up the numbers in each outcome of green and red die. Now that we have completed the sample space of rolling two dice, let's figure out what sums can we get to determine the values of random variable x. So as you can see, we only have values between 2 and 12 inclusive. Therefore, the possible values for x are the whole numbers from 2 to 12. The random variable x as a function is illustrated wherein it assigns to an element in a sample space, say 1, 5, a unique real number which is 6. It is indicated by the arrows in the figure. The outcome 6, 4 is mapped also to a real value of the random variable x which is 10. That is the sum of spots as a result in rolling a pair of dice. Let's consider another problem. Next example. Para mas maintindihan, sabihin natin na ang bibigyan muna ng payong ay si Alice, pangalawa si Belle, panghuli si Carla. This is only the preferred assumption. The names must be in alphabetical order to make it simpler. The possible values of the random variable that we will get is still the same regardless of the order in which Alice, Belle, and Carla each receives one of the three umbrellas. Ito ay para din may basehan tayo kung natanggap na ba nila ang kanya-kanyang payong sa pagkuha natin sa mga values ng random variable y. Dahil di alam ng security guard kung kani-kanino o sino ang tiyak na nagmamay-ari ng payong, alamin natin lahat ng mga posibleng pagkakasunod o mga paraan sa pagsauli ng payong. There are 3 factorial or 6 ways to return each of the 3 umbrellas. Para mas madali nating maipakita ang sample space, gamitin na lang natin yung unang letra ng kada pangalan sa paglarawan ng kanya-kanyang payong. Ibig sabihin, ang payong ni Alice ay tatawagin nating A, letrang B naman ang magsisilbing payong ni Belle at C para kay Carla. Kung ililista natin ang mga elements sa sample space, 6 lahat. So you will represent that list as S, and those outcomes are ABC, ACB, BAC, BCA, CAB, and CBA. Pagkatapos natin makuha yung ating sample space, gagawa tayo ngayon ng table para malaman natin yung mga values ng ating random variable y. Sa table natin, ito yung magiging itsura ng table. Para sa table, Lagay tayo ng dalawang column, pwede rin ganito, para mapakita natin ang mapping. So we have here first the outcomes or elements of S. And then the second column is for the particular value of the random variable y denoted by small letter x. As indicated in the problem, remember that we need to find the values of the random variable y defined as the number of clients who receive their own umbrellas. Hahatiin natin yung nasa baba ng table sa 6 na rows kasi meron tayong 6 na posibleng mga outcomes. Now, from the sample space, we fill in the first column of the table with all the outcomes. Next step, in order to determine the particular value of the random variable y in each outcome, we simply compare the outcome to the assumed order ABC as mentioned at the beginning of our solution, meaning Alice will be receiving first her umbrella, next Belle, third Carla. Kaya dyan natin ibabase kung tama ba ang pagkakasauli ng payong, kung tugma sa pagkakasunod-sunod. Dahil parehas ito sa kung sino muna ang makakatanggap ng payong. Una si Alice, pangalawa si Belle, huling mabibigyan si Carla. Isa itong ABC sa mga outcome, o parehas ito sa unang outcome. Kaya 3 ang isusulat natin sa pangalawang column. Ibig sabihin nito, lahat sila nakatanggap ng tamang payong. Sunod na posibleng outcome ay ACB. Nasa tamang pwesto ang A kung ihahambing natin sa tamang pagkakasunod-sunod ng ABC. Kaya ibig sabihin, si Alice lang ang nakakuha ng kanyang payong. Kaya ang value ng random variable ay 1. Ganon din sa BAC. Isang letra lang ang nasa tamang pwesto o si Carla lang ang nabigyan ng tamang payong. Dito naman BCA. Dahil ditugma sa ABC, 0 naman dito. Kasi wala naman sa kanilang nakakuha ng tamang payong. Parehas din sa CAB. At sa huling outcome, CBA. Ibig sabihin naman ito na nasauli kay Belle ang kanyang payong. Kaya isa ulit ang ilalagay natin dito. We therefore conclude that the values of random variable y is 0, 1, and 3. Base dito, pwede rin nating sabihin na lahat, isa lang o wala sa kanila ang makakatanggap ng kanyang payong kung titignan natin lahat ng mga posibleng paraan para maibigay ito ng security guard. Third and last example. Solution. Let A be the event of drawing an ace card, and let N be the event of drawing a non-ace card. The sample space would consist of an unending sequence of elements S, which are A, and A, and an A, and an A, and so on. Thus, the random variable Z would assume the values of positive integers 1, 2, 3, and so on. Sa madaling sabi, pipili tayo ng isang baraha, ibabalik kung hindi ace, ibabalasa at uulitin ito hanggang sa makakuha tayo ng ace. Ibig sabihin, palaging kompleto o hindi bawas ang barahang pagpipilian natin. So in this experiment, we will expect that the last event is always an A, which means an ace card is finally drawn, and all the previous events are represented by N, indicating that an ace card is still not drawn, or a non-ace card has been drawn instead. Para mapasimple, kung ilang beses ka nagpili ng baraha o ilan ang letra dito sa bawat element ng sample space, yan na mismo ang value ng random variable Z. Therefore, the sample space S has an infinite number of elements or outcomes with corresponding values of random variable Z that is the set of all positive integers. Now, random variables can either be discrete or continuous. Ano nga ba ang pinagkaiba ng dalawa? First, discrete random variables are random variables that can take on a finite or countably infinite number of distinct values. Sabi dito, pag discrete random variables daw, mabibilang natin ang outcome o kung whole number siya. The following can be modeled as discrete random variables as you can get whole numbers of these. The number of heads obtained when tossing a coin thrice. The number of cities in Bicol to go for vacation. The number of students watching this video lesson at a given time. And the number of crushes a person has at a particular time. On the other hand, continuous random variables are random variables that take an infinitely uncountable number of possible values, typically measurable quantities. Okay, in simple terms, some random variables are continuous, which means that they take any value within a range, including fractions. So when we say continuous random variables, it is commonly the result of measurement, and each set of possible values contains a whole interval of decimal numbers. Kaya ito lang tatandaan natin. Ang random variable ay continuous kapag nakabase ito sa sukat at kung nakadesimal, o hindi siya whole number. Examples: if we wish to model the height or weight or BMI of a person, if measured very accurately, it would take a range of values in centimeters or grams. The time a student spends answering his or her module, and the time it takes for a person to eat his or her breakfast, these would both be continuous random variables measured in hours or minutes or in seconds. The number of places a class wants to visit for vacation, as there are infinitely possible destinations for vacation and cannot be counted. We can also define another random variable y to be the time a person can hold his or her breath. Masyado kasing madami ang posibleng value ng ating variable dito. In this example, the possible values range between the lowest and the highest value recorded. Pansin natin na mahirap talaga ilista lahat ng mga pwedeng maging value dito. That is why, in this case, it's better to state the possible values as an interval, such as y is greater than or equal to 10 and less than or equal to 60, if the lowest and highest values are 10 and 60, respectively. Therefore, the values that a continuous random variable can have lie on a continuum, such as intervals. So in other words, continuous random variables also can represent any value within a specified range or interval and can take on an infinite number of possible values. And there you have it. We just finished discussing about random variables. And to make sure you still have them in your mind, let us do this activity entitled Test Your Math Skills. I will give you some time to answer each item. For the directions, given the following experiments and random variables, identify what the possible values of the random variables are. Also, for each random variable, underline if the given variable is discrete and encircle if continuous. If you are using the class point, you will just draw on the slide and quickly submit your output. In this video lesson, make sure again to have your pen and paper ready, and this time you need to interact with your group mates online as assigned earlier in the group chat of the class. The chosen leader will be the one to submit the output of the group in the Google Classroom after this video lesson. You will still copy the statements in each item to indicate if the given random variable is discrete or continuous. Are you ready, students? Well, that's good to know. Pause this video and kindly do the group activity in 10 minutes. Now let's have a quick run through of the lesson. As a recap, we have the following key points. A random variable may be viewed as a way to map outcomes of a statistical experiment determined by chance into number. There are two types of random variables. We have the discrete random variable, which takes on a finite or countably infinite number of values, while the continuous random variable takes an infinitely uncountable number of possible values, typically measurable quantities. In this lesson, we need to understand that random variables are conceptually different from the mathematical variables that you have met before in math classes. A random variable is linked to observations in the real world, where uncertainty is involved. Random variables are central to the use of probability in practice. They help model random phenomena. That is, random variables are relevant to a wide range of human activities and disciplines, including agriculture, biology, ecology, economics, medicine, meteorology, physics, psychology, computer science, engineering, and others. They are used to model outcomes of random processes that cannot be predicted deterministically in advance, but the range of numerical outcomes may, however, be viewed. Did you enjoy watching this video lesson? Did you also learn a lot today? Any clarifications, suggestions, or violent reactions with regards to the video lesson? If so, after watching the video, tell us your thoughts by adding a private comment in the Google Classroom. I will be so glad to hear, see, and read your learnings in this video lesson. Also, rate your understanding using the given learning scale. React the shared link of this video in the group chat or send your reactions in your private comments in the Google Classroom to reflect about your learning represented by the following. Please refer to the emojis given and pause this video for you to be more familiar with the learning scale. Now that we are done with the lesson proper, it is now time for you to do the assessment. Let's have a 5-item short quiz to test the extent of your understanding of today's lesson. I will be using the live competition mode in the class point to rank and score you based on your responses to all of the multiple choice questions. Since these are competition questions, there will be a leaderboard that displays the top 6 students based on if they chose the correct answer and how fast they submitted it. Once the question appears, the timer will count down automatically. I will give you only 2 minutes to choose the letter of the answer from the options provided. Good luck! Question number 1. Hands up. The correct answer is A. Nakuha niyo ba ang tamang sagot? Congratulations! Let's check the leaderboard. So we have Roy in the first place with 1,000 points. Great! Let's proceed to the next question. Number 2. Okay, C is the correct answer. Did you get it? That's amazing. Of the scoreboard, still we have Roy in the first place with 2,000 points. Good job. Item number 3. Okay, it is letter D. Are you correct? Good job! Again, we have Roy in the first place with 2,664 points. Next, number 4. Okay, letter C is the correct answer. Did you answer it correctly? Excellent. Let's check the result. Oh, for the third place, we have Jessamy with 3,917 points. And ranking second, we have Bea Joy with 3,991 points. And in the top one, who got a total of 4,648 points. Congratulations to Lizelle. Did you get all the items correct? I believe you answered it perfectly. Very good. Also, you can go back to the items to understand the problems better. But in the meantime, for the additional activities and continuation of our lesson, please refer to your Quarter 3 Learning Activity Sheet 1 in Statistics and Probability. And of course, before I forget, for your assignment, create a traditional poster about the importance or real-life applications of statistics and probability. You will be graded based on this rubric. Congratulations! You did a great job in this video lesson. I hope you learned something new today. And by the way, please feel free to message your teacher for further clarifications of the lesson. I and your respective teachers would be glad to assist you. That would be all today. Once again, I am Sir Christian J. Binodalo. Learning is not memorizing the exact words from the book. Learning is about and being able to explain it in words. Have a good day.